everyone. In this video we'll solve some trigonometry problems and also derive some useful information. So consider two right angle triangles, 45 45 90 degrees right angle triangle, 30 60 90 degrees right angle triangle. So using these two triangles, we'll find out the value tan 75. Okay, so what is the value of tan 75 minus cos 75 degrees? So tan A plus B is tan A plus tan B, 1 minus tan A tan B. If you watch my previous videos, we derived this equation. So tan 75 can be written as tan of summation of 30 plus 45. So tan 30 plus tan 45 divided by 1 minus tan 30 tan 45. Using those right angle triangles, substituting tan 30 and tan 45 values, we'll see tan 75 as root 3 plus 1 divided by root 3 minus 1. Similarly, cos 75 is nothing but root 3 minus 1 by root 3 plus 1. Now tan 75 minus cos 75, doing some arithmetic calculations, we can come to the conclusion that it is 2 root 3. So the answer is 2 root 3 here. So similarly, if we know tan 75 is root 3 plus 1 root 3 minus 1, so which is opposite side by adjacent side. Again, look into the right angle triangle. Tan 75 degrees is opposite root 3 plus 1, and adjacent side is root 3 minus 1. So hypotenuse is nothing but 2 root 3 based on Pythagoras theorem. So if you note down tan 45 degrees plus 30 degrees in terms of two right angle triangles where we have angles 45 and 30, and substitute instead of the values alpha bits which represents the opposite sides, then we can see tan of two angles is nothing but the opposites of tan of two angles is nothing but AE plus DB. AE is nothing but adjacent side of one right angle triangle multiplied by opposite side of second right angle triangle plus adjacent side of second right angle triangle multiplied by opposite side of first right angle triangle, and adjacent side of tan of two angles is DA minus EB. DA is nothing but product of two adjacent sides of the two right angle triangles minus product of opposite sides of two right angles triangles, and hypotenuse nothing but product of two hypotenuse. Hypotenuse of summation of two right angle triangles is nothing but product of two right angle triangles. Using this trick, we can solve some problems easily. So to summarize, if you have right angle triangle with angle theta 1 and another right angle triangle with angle theta 2, then tan of theta 1 plus theta 2 is, which is a new right angle triangle which is an opposite side 3 by adjacent side, is nothing but opposite side is adjacent side of first right angle triangle multiplied by opposite side of second right angle triangle plus adjacent side of second right angle triangle multiplied product of first right angle triangle. And this new adjacent side 3 is product of two adjacent sides minus product of two opposite sides of two different right angle triangles. Hypotenuse is nothing but product of two hypotenuses. So adjacent side 1 is adjacent side of triangle 1, adjacent side 2 is adjacent side of triangle 2. Similarly, opposite side 1, 2, adjacent side 3 is adjacent side of new triangle, right angle triangle, which has an angle which is sum of two angles of right angle triangles, that is theta 1 plus theta 2. Similarly, opposite 3 we have, and hypotenuse 3 we have. So now let's use that to solve the problem again for the tan 75. So we have two right angle triangles. So how do we calculate tan 75, which is tan 45 plus tan 30, right? So we have tan 45, adjacent side is 1 and opposite side of second right angle triangle is 1, so 1 into 1 plus adjacent side of second right angle triangle which is root 3. So second right angle triangle angle 30, with respect to angle 30, adjacent side is root 3 multiplied by opposite side of first right angle triangle is 1 divided by product of two adjacent sides 1 into root 3 minus product of two opposite sides. So again, doing some calculation, we can say its tan 75 degrees is nothing but 2 plus root 3. So one of the trick we used is root 3 plus 1 by root 3 minus 1 is the tan 75, then we multiplied and divided by root 3 plus 1, and doing the calculation we got tan 75 as 2 plus root 3. Now similarly, let's calculate tan 105 105 degrees sine 105 cos 105 sine 75 cos 75. So remember opposite side 3 what it is, adjacent 3 what it is, hypotenuse 3 the new hypotenuse what it is. So tan 105 so is we can write as 60 plus 45 degrees, right? So adjacent side of at 45 is 1 multiplied by opposite side is root 3 plus uh, uh, plus adjacent side of another one is 1 opposite side of another triangle is 1, it's 1 into 1. So we are writing tan 45 plus 60 degrees. So divided by product of adjacent sides 1 into 1 minus product of opposite side 1 into root 3. So doing little calculation we'll see it as minus 2 minus root 3. Similarly sine 105 which is uh, again opposite side is of new triangle is what we have, that opposite 3. So using 1 into root 3 plus 1 into 1 divided by hypotenuse product of 2 hypotenuse 2 root 2. So it is root 3 1 plus 1 by 2 root 2. Similarly cos 105. Cos 105 a of a new triangle is what? Adjacent side is what? Summation of adjacent sides which is 1 into 1 minus summation of opposite sides which is 1 into root 3 by hypotenuse 2 root 2. See again cos 105 is nothing but cos 45 plus 60 degrees. Now sin 75 is nothing but we calculate tan 75 before, so it's the same thing. Sin 75 is opposite side of two right angle triangles. Sin 75 is like you need to take angles 45 degrees and 30 degrees pointing towards the top, because 45 plus 30 is 75. So 1 into 1 plus root 3 into 1 divided by hypotenuse 2 root 2. Similar cos 75 is 1 into is multiply both adjacent sides, that is adjacent side for first right angle triangle 45 degrees towards point, if we take 45 degrees towards upwards as adjacent side then it's 1, and for the 30 degrees adjacent side is root 3. So product of two adjacent sides 1 into root 3 minus product of opposite side 1 into 1 divided by product of two hypotenuse 2 root 2. So it's root 3 minus 1 by 2 root 2. Now so prove sin 2a is 2 sin a cos a, and cos 2a is cos square a minus sin square a. So we know sin a plus b, which if you watch my previous one of the videos where I proved sin a plus b is sin a cos b plus cos a sin b, then let's just put b is equal to a. In the scenario where b is equal to a, we have sin 2a which is sin a cos a plus cos a sin a which is 2 sin a cos a. So we just proved sin 2a is 2 sin a cos a. Similarly, we proved before cos a plus b is cos a cos b minus sin a sin b. Now let b is equal to a. Which results in cos 2a as cos a minus sin a sin a, which is equal to cos square a minus sin square a. So again we proved cos square a minus sin square a. Similarly, let's go and prove certain other equations. Cos minus a of minus a is cos a, sin of minus a is minus sin a, which we can figure it out from the plots. Sin of 90 minus theta is called cos theta, cos of 90 minus theta is called sin theta, tan of 90 minus theta is called. So those are the other equations. In the previous pages we proved sin 75 degrees as root 3 plus 1 by 2 root 2, which is equal to sin of 90 minus 15 equals to cos 15, because sin theta is equal to sin 90 minus theta is equal to cos theta. Similarly, cos 90 minus theta, cos 90 minus 15, which is cos 75 equal to sin 15. Similarly, tan 15, tan 90 minus theta, so which is tan 90 minus 75 degrees is tan cot 75, and tan 15 is equal to cot is nothing but tan of 90 minus 75, which is cot 75, and similarly we have tan 75, which is root 3 plus 1 by root 3 minus 1. So let's go to the next equation. So we proved cos a minus b is cos a cos b plus sin a sin b. We need to prove that. So we know cos a plus b as cos a cos b minus sin a sin b. Now If you put b is equal to minus b, then we have cos a of cos a and cos of minus b minus sin a sin of minus b. But we know cos of minus b is cos b and sin of minus b is minus sin b. If you substitute that, we have cos a minus b as cos a cos b plus sin a sin b. Similarly, sin a cos b minus cos a sin b equals to, if we need to prove that it is equal to sin a minus b, we know sin a plus b is sin a cos b plus cos a sin b. Again, if we put b is equal to minus b in the above equation, we have sin a minus b equals sin a cos of minus b plus cos a sin of minus b. Again, we know cos of minus b is cos b, sin of minus b is minus sin b. If you substitute that, we have sin of a minus b is equal to sin a cos b minus cos a sin b. Also, we know tan a is nothing but sin a by cos a. So tan of minus a is sin of minus a by cos of minus a. But cos of minus a is nothing but cos a, and sin of minus is minus sin a, which results in minus tan a. So therefore tan of minus a is tan minus tan a. Since tan a plus b is tan a plus tan b by 1 minus tan a tan b, if you put b is equal to minus b, we will get tan a minus b, which is equal to tan a plus tan minus b divided by 1 minus tan a tan minus b. But tan minus b is minus tan b, so tan a minus b is nothing but tan a minus tan b divided by 1 plus tan a tan b. So that's an important derivation. Similarly, since we have tan a minus b as tan a minus tan b by 1 plus tan a tan b, now let's solve another problems. Sine of 45 by 2, which is 22.5, cos of 45 by 2, tan of 45 by 2. Since we derived sine a minus b, cos a minus b, let's see how we can solve this equation. So we know cos 2a is equal to cos square a minus sin square a. Now add and subtract sin square a on both sides. Not on both sides, on the same side. If you do it, cos square a plus sin square a minus 2 sin square a, but we know cos square a plus sin square a is 1, which means 1 minus 2 sin square a. So sin square a is nothing but 1 minus cos 2a by 2. Sin square of 45 by 2, which is 22.5, is nothing but 1 minus cos 45 by 2. But we know cos 45 as 1 by root 2, so divided by 2. So therefore we have sin square as root 2 minus 1 by 2 root 2, and we can further simplify into sin a as under root of 2 minus I mean it's a square root of 2 minus square root of 2 divided by 2. But the basic idea is we need to derive sin square a in terms of values we know. Since we know cos 45 degrees and we are trying to find sin of 45 by 2, we derive sin square a in terms of cos 45. Similarly, we can derive cos also. So let's see. But again, and similarly we can derive what is cos square a, which we will do in a different video. Thanks for watching this video.